Before we go into the problem solving, I once again want you to have a look at this summary of chapter 3 so that before we go into problem solving, we have a rough sketch of chapter 3 in our mind. For chapter 3, we started with defining formally what is a random variable. We said a random variable is a function that assigns numeric values to each outcome in the sample space. We said a discrete random variable is a type of random variable that takes either finite or countable number of values. Then we said a probability mass function. It's a function that gives you the values of a random variable along with the corresponding probabilities. This probability mass function can be in terms of a function or it can be in terms of a table. Both ways, it's called probability mass function. So either a table or a function that gives you all the possible values of a random variable x along with the corresponding probabilities. This is called a probability mass function. Now, this probability mass function can be used for some of the things. What are those things? Number one, it can be used to find the cumulative distribution function that gives you the less than equal to probabilities. It can be used to find the mean of a random variable. It can be used to find the variance of a random variable. It can be used to find the standard deviation of a random variable. Then we moved on towards some special distributions, special discrete random variables. And these discrete random variables, they are so commonly used in practice that they are given special names. What are these? One of them is a binomial random variable, one of them is a hypergeometric random variable, and one of them is a Poisson random variable. These are some types of discrete random variable that we find their application so much in the real life that we have given them special names. What is a binomial random variable? We said that binomial random variable x is a variable that counts the number of successes out of n independent trials. What is a hypergeometric random variable? We said a hypergeometric random variable is a variable x that again counts the number of successes out of n trials when the selection is without replacement from a finite population. Yes. So, and the polynomial. Either with replacement or from infinite population. Even if it is without replacement, it should be from infinite population so that taking one out does not reduce the size of population. And finally, Poisson is again a random variable that counts the number of successes, but it counts the number of successes per unit, any unit of time, space, weight, any unit. Today, now we plan to move towards problem solving related to these 1, 2, 3, 4, 5 concepts. The discrete random variable basic definition, the probability mass function, and the three popular discrete probability distributions. Let us start with question number 1. I have hidden the answers with a black mark today. So you will see the wrong answers, but you will not see the right answer. You have to reach the right answer. This first question says that let f of x, which is c multiplied by 1 over 2 to the power x, be a probability mass function. It says that it is a probability mass function. Determine the value of constant c. Determine the value of constant c so that the function f of x satisfies all the conditions of being a probability mass function. What are the conditions of probability mass function? Here are the conditions. What are those conditions? Number one, the functional values, they must be non-negative. Number two, the sum of all the values over the whole domain of x should be 1. So I'm going to make use of these conditions to find the value of c. First, let us make a table of the values of x and the corresponding probabilities that will help us compute c. What are the values of x which are possible and given to us? 1, 2, 3. What are the corresponding probabilities? Put 1 in that one. C by 2, not half. C by 2. Put 2 in the function. C by 4. Put C by 8. So let me write this one as 2C by 8 and this one as 4C by 8 so that I can easily find the sum. Now, the property of mass function says that the sum of these values should be 1. The total should be 1. So add these values, 4C over 8 plus 2C over 8 plus C over 8 equals 1 and solve this equation for C. So this is 4 plus 2, 7C over 8 equals 1 and C will be 8 over 7. So now I unhide the answer for you, which is 8 over 7. Any question from this? I think this is 233, term 233 exam. Okay, yes.
There's some examples that will have unlimited numbers. So X will be 1, 2, 3.
Unlimited numbers?
Yes, to infinity. 1, 2, 3.
For Poisson distribution, yes, we have. But we'll not ask you to find C in that case. It's tough to find. For Poisson distribution, it has an unlimited domain. X starting from 0, 1, 2, 3, 4, all the way up to, look here. Where is Poisson? Look at blue. We'll look at the domain. Number of successes per unit. Can be anything. Okay, let us move on towards another question. This question says that if f of x equals this is a probability mass function of x here. This is the mass function now with 5 possible values. We are supposed to find the probability of x greater than 1 given x is less than 3. So apply the conditional probability formula. What is that? We are required to find probability of x greater than 1 given x less than 3. What is probability of A given B? This will be given to you in the formula sheet. This, what you see on top of the screen, is given to you in the formula sheet. That probability of an event A given another event B is equal to probability of A and B divided by probability of B. Now you can call this one to be your event A and you can call this one to be your event B. So apply the formula. What do you get? Yes, I will write that. Probability of A and B divided by probability of B. Now, what are the values of x which are possible such that they are greater than 1 and also less than 1 and less than 3? What are the values of x inside? What are the values of x among these values which are greater than 1 and at the same time less than 3? Why am I saying and? Because of this intersection, I'm saying and. They are greater than 1 and they are less than 3. What are those values? Only 2. And what are the values of x which are greater than 3? Sorry, less than 3. 0, 1, 2. So this is probability of x equals 0, equals 1, equals 2. Right? Just plug in. Now, what is the probability that x is 2? 2 times 4 plus 1. 5 over 25. 1 over 5. Over, what is the probability that x is 0? Yes. 1 over 25. X is 1. 3 over 25. X is 2. 5 over 25. So you get what? 25 cancels with 25. So you have 5 divided by 8. 5 by 9. Which is 0.56. Is it? Is it 5 over 9? Yes. Yes. Any question? No question? Let's move on to another problem. This problem again from term 233 that says that in some kind of batteries, a fully charged cell is composed on something hydroxide. Nickel is an element that has multiple oxidation states that is usually found in the following states. So the values of nickel charge are given and the corresponding probabilities are also given. Okay, again, this is a probability mass function of x. X is the nickel charge. So call this one to be your x. The possible values of x are what? 0, 2, 3, and 4. 1 is not a possible value. So if in this question I ask you to give me the probability that nickel charge is 1, what will be your answer? 0. Any value that is absent in this table, the corresponding probability by default is 0. Okay. Now let us see what the question is. The question says that the probability of a nickel charged option within 1 standard deviation from the mean. Very complicated question. Within 1 standard deviation from the mean. What is that probability? What do you mean by within 1 standard deviation of mean? Yes, plus or minus what? Who said? Plus or minus how many standard deviation? 1 standard deviation. So this is mu minus sigma and mu. So you see, there is a lot of computation you have to do before you get to the point where you know what is required. You need to compute what? Mu. You need to compute what? Sigma. You plug in, then you will get to know what exactly is required. So let us first find mu and sigma. You have a column of x. You have a column of f of x. You need how many new columns? 2 new columns for finding mean, and you need x times f of x, and you need x squared times f of x. So let's find that. What is 0 times 0.17? What is 0 squared times 0.17? What is 2 times 0.35? 0.7. What is 2 squared, which is 4 times this one? What is 3 times 0.33? Somebody get a calculator. I will stop guessing at a specific one. What is 9 times 0.33? 9 times 0.33. If we don't get the correct answer, -1. 4 times 0.15. 0.6 and 16 times 0.15. 2.5. Now give me the sums of these two. 2.4 and expected value of x square, the sum of the last column. Take out the calculator. Will not be able to find sigma because I need the expected x minus 2.4 square.
Last value of the x squared is not 2.4.
It is not 2.4. This is 2.4.
Yes.
Who said 2.5? Give me the sums quickly.
The first column is 2.2.
That's the expected value of x mean. The second column, 6.77. Now give me sigma, which is 6.77 minus 2.29 square. This formula will be given to you again in the formula sheet. Sigma equals expected value of x square minus expected value of x whole square, square root. I missed the square root here. After square root? 5, 3. Now give me 2.29 minus 1.2353 and 2.29 plus 1.2353. Now, what are the values of x look at the table. What are the values of x which are between these two, but not including these two, between these two? At the end, the question was easy. You just had to add 2 and 3, this and this. 0.35 plus 0.33, which is 0.68. But to reach to a point where you know what is required, you had to do a lot of calculations. Yes. This is an A plus question. This is without a doubt A plus question. The most difficult part of this question is here, to understand what is required. Read the last line and understand what is required in the question is the most difficult part of the question. Any question? Let us move on to another problem. Yes.
Good question. Yes, because the ability of challenge 2 and 3 of the most.
No. No. We might play around with the probabilities in such a way that within plus minus 1 standard deviation will not be the most. Okay, this is one of the examples that we did in the class while discussing one of the distributions. I will not name that distribution, but we did this question in the class. The question says that you assume each sample of water has a 10% chance of containing a pollutant. 10% chance of containing a pollutant. Assume that the samples are independent. Find the probability that out of next 18 samples, out of next how many samples? At least 3 contain the pollutant. Binomial. We did that in the class. Now, from the binomial, I want you to identify what is given in the first line. 10% is what? What is success? No, the definition of success. That the sample contains pollution. How many samples are you collecting? So n is fixed, right? Independence is given. X is what? Number of successes out of 18. Out of 18, you are interested in how many of them they contain the pollutant, right? And what is required in terms of X? I want you to read this line and tell me what is required in terms of X. At least 3. Now, first thing you need to tell me what is the mass function of X in this case. I will use notation. X follows binomial. Job number 1 done. After job number 1, you have to look into the formula sheet for the mass function of binomial. And when you look into the formula sheet, the mass function of binomial will be written like this. In this whole function, apart from the unknown variable x, how many unknown constants do you see other than x? 2. You see n and you see p, right? Now, after recognizing that x has a binomial distribution, you need to find these two numbers from the question. What is n and what is p? N is 18 and p is 0.1. That's it. That's all solution. You don't need to do much now. So the required probability, if you solve it directly, how many probabilities you have to find? You have to find probability. If you solve it directly, you have to find probability x equals 3 plus x equals 4 plus all the way up to x equals 18. Too many probabilities. So what will you do?
Complement.
You will use the complement rule and you will say this is equal to 1 minus probability of x less than 3. Remember, in complement rule, if equality sign is here, don't put the equality sign on the complement. If equality is not there, put it here. So equality sign is very important for discrete random variable. It has to be somewhere, either with the original event or with the complement. What are the values of x which are less than 3? Now it's just plug and get the answer. What is the probability that x is 0? 18 combination 0, 0.1 to the power 0, 0.9 to the power 20. Why did I write it up there? 18, sorry. Plus 18 combination 1, 0.1 to the power 1, 0.9 to the power, plus 18 combination 2, 0.1 to the power 2, 0.9 to the power 16. Solve these three and you will get this answer, 0.2662. Okay. Any question? This was one of the easier ones. Why? Because we did that in the class. Number 10, this is tough. This is tough because we did not discuss this kind of concept directly in the class. They have a variable. They say this variable follows a distribution and they do not give you the PDF. They give you the CDF. They do not give you the mass function. They give you the CDF. In the class, we knew how to get CDF from the PDF by adding downwards, right? But we very briefly discussed how to get PMF from CDF. So this question demands you get the PMF from CDF and then you find this corresponding probability. Or you can also find it directly from the CDF. I will tell you both ways. Number one, I will tell you how to find it directly from the CDF. Okay. So what is required? By definition, this CDF is actually the probability that x is less than equal to that value. Remember this definition in your mind. That CDF is actually a sum of mass functions. So it gives you less than or equal to probability. Then what is required? Required thing is probability of x greater than 2. You have to convert it to that definition. So how do you do that? Complement, use the complement. This is equal to 1 minus probability of x is less than equal to 3. What is this? This is f of 3, 1 minus capital F of 3. And this is 1 minus, what is capital F of 3? 0.7. Capital F of 3. Capital F of any value between 1 and 4 is 0.7. So capital F of 1 is 0.7. Capital F of 2 is 0.7. Capital F of 3 is 0.7. What is capital F of 4? Not 0.7, 0.9, because equal sign is later here in the next. So capital F of 3 is 0.7 and the answer comes out to be 0.3 directly using the CDF. What if they ask you to find the mean of x, not the probability? Now, mean cannot be found through the CDF. For mean, you must have the mass function. What is mean? You must find this guy. To get the mean, you need a column of mass function, right? So you must have to take now the differences and get the mean. If a question says you have to find the mean, then think of it like this. Subtract backwards and get PMF, and then from PMF you get the mean. What is the capital F of anything less than 1? 0. I will plot it now. 0. So it's 0 here. The moment you reach 1, CDF becomes what? Let me say this is 0.2, 0.4, 0.8, and 1. So it becomes the moment you reach 1, the CDF immediately jumps to 0.7. Then it stays 0.7 until you reach 4. Then when you reach 4, CDF again suddenly jumps to 0.9 here. And it stays 0.9 until you reach 7, 5, 6, 7. And then suddenly at 7, it became 1. And after 7, it's 1. Throughout 1, right? This tells me that there was no density before 1, right? Then suddenly at 1, how much density was added to the CDF? 0.7. Then after 1, no density is getting added. So the probability mass function at 2 is 0, 3 is 0. Then at 4, again, there was some density added. What was the amount of density which was added? 0.2. So the mass function at 4 is 0.2. Then the mass function at 5 is 0. 5 is not a possibility. 6 is not a possible value. No mass was added. Then suddenly little bit more mass was added at what? 7. How much was added? 0.1. So this way you can get the mass function back like this. You have x, 1, 4, and 7. And the probability of x equals x, this is 0.7, 0.2, and 0.1. Now you multiply the two columns and you can find the mean. This is a plus question. If we give you a CDF and ask you for the mean or standard deviation, you are bound to go back and get the mass function, and from there you get the mean or standard deviation. Yes.
So the
Rest are zeros. Mass function at 2 is 0, at 3 is 0, because nothing was added at 2 or 3 from the CDF. Nothing was added. From here also, if you want to go back to the CDF, that means probability x less than equal to x. Keep adding downwards. 0.7, 0.7 plus 0.2, 0.9, 0.1. Do you get the same function back? Yes. Three includes everything less than equal to 3. Capital F, the definition of, look here. Pay attention to this definition of capital F. The definition of capital F means probability of x less than equal to that number. The definition of small f means probability of x equals to that x. And in the first attempt, I was not using small f. I was using the capital F. Okay. Any questions? Let's move on to another question. Don't expect this type of question very commonly where they clearly give you the name of the distribution. This is a C or C plus question. The question says that the number of errors in a textbook, they follow a Poisson distribution with mean what? There is a trick in this one, but a very small trick. With mean what? 0.01 per page. And the required is what? What is the probability that there are 3 or less errors in how many pages? Probability that the number of errors is less than or equal to 3 per how many pages? 100 pages. What is the distribution of x? Poisson, with lambda equals 0.01 per page. But the question is about per 100 pages. So once you open this question, you will put lambda times 100, lambda times t. Here t is 100. This will be given to you in the formula sheet. Okay. you have to identify from the question, once you identify that X has a Poisson distribution, the next thing is to identify the value of lambda, number of successes per unit, and the number of units question is about. If the question is about single unit, this will be 1. For example, if I give you the number of errors per page and ask question number of errors per page, T will be 1. But here T is 100. Why? Because I'm giving you number of errors per page, looking for number of errors per 100 pages. So this will be opened like probability of X equals 0, X equals 1, X equals 2, X equals 3. A small question, can I solve this one with the complement rule? Can I solve this question with the complement rule? Longer or not longer? Can I?
From 4 to
I cannot, because there is no upper bound of Poisson. You will go from 4 up to what?
less than 3 or bigger than 3?
The question is less than equal to 3.
How bigger than 3?
Can I make it bigger than 3? I can make, but I will not able to solve it because there is no upper bound of the Poisson. So for Poisson distribution, even if the question is bigger, you must convert to less than, because there is no upper bound of Poisson. You cannot add probabilities all the way up to infinity. Must bring it to less than.
Isn't it bounded?
No. In the 100 pages, how many errors can be there? There can be 1 error, there can be 2 errors, there can be 1,000 errors, there can be any number of errors. So how will you find this? Now the trick, last trick. How will you find probability of X equals 0? By plugging in X equals 0 in that function on the right top. E to the power minus, what is lambda? 0.01. What is T? 100 times 0.01 into 100 whole to the power 0 over 0 factorial plus same thing. And the answer will be 0.9810. Any question? We are done with 233. Now let me quickly move on towards 241. The first question of 241 says that an assembly consists of 2 mechanical components. Suppose that the probabilities that first one meets the specification is 0.95 and the second one meets the specifications is 0.98. First one meets the specification, second one meets the specification. Assume that the components are independent. 2 of them are independent. Which one of the following is the correct mass function for the? This is a question from the general definition of discrete random variable. What is the mass function of this X? To get the mass function, first you need to identify what are the possible values of X, and then you have to find the corresponding values of X. This table is called a mass function. Okay. So first try to find the possible values of this random variable X, which is the number of components that meet specification. How many components are there total? 2 components. Here, look at the first line. How many components? There are 2 components. Out of the 2 components, how many can meet the specification? Maybe 0. Maybe one of them meet the specification. Maybe both of them meet the specification. So these are all possible values of X. Next thing is to find the corresponding probability. What is the probability that none of them meet the specification? The first one does not meet the specification and the second one does not meet the specification. And probability of S1 complement intersection S2 complement. First one does not meet the specification and second one does not meet the specification. The question says that they are, where is the word independent? The question says they are independent. When they are independent, intersection turns into what? Multiplication. So this is S1 complement into, What is the probability that the first one does not meet the specification? Meet the specification is given, so does not meet will be 0.5 times 0.02. What is the probability that one of them meets the specification? Which one? You will discuss both cases. Probability that the first one meets the specification, but the second one does not, plus probability that the first one does not meet the specification and the second one does. What are these probabilities? Now find them. Because of independence, again, these probabilities will turn into product. Now, what are these probabilities? What is the probability first one meets the specification? Second one does not. First one does not. Second one does. Then the third value. Probability that X is 2. X is 2 means that both of them meet the specification. .95 times 0.98. Once you get these three values, you have to match those three values, match with which one of these options, and they will match with this one option. Yes.
Second one, add them all, right?
Add the two cases, not add them all. Yes. Yes.
I just find one.
One of them will be correct. No more than one can be correct.
I mean, we now found X equals 0, X equals 1, X equals 2. We do not need the three of them. Just we find, for example, X equals 0.
Well, first two match. Maybe we give you the two options where the first two match, third one doesn't match.
Yeah, so I found that.
We know what you will think. So maybe you have two options where these two are same. Did I give? By the way, this is the exam that I made. Luckily, it was not there, but maybe there are two options, A and B, where probability of 0 is the same and 1 is also the same. But for 2, it's
I have to find that.
no, you have to match all three of them. You have to match all three of them. What if there was another option here? Probability X equals X1, 0 equals 0.001. X equals 1 equals 0.068. And probability X equals 2 equals 0.831. Now, in the presence of option F, you check only first two. Only first two are true for this and also for this. Yeah. If you find any one of them to be not matching with the correct solution, that means that option is wrong. But if you come from the elimination strategy, you have to check 4 eliminations.
But the probability,
It's for two, all options different.
but enough,
Yes.
it will not sum up to 1.
Yeah. It's incorrect in another way that they are not summing up to 1. B or B plus question. The range of a random variable X is from 1, 2, 4, 7, and the last value of X is not given. Okay. Each value of X is equally likely. What does that mean, equally likely? They have the same probability. How many values of X are there? 5 values. So each value has what probability? 1 over 5, 1 over 5, 1 over 5, 1 over 5, 1 over 5. So this is very, very important. Equally likely. We are not giving you the probabilities directly. We are giving you indirectly by using the word equally likely. Clear? Then another piece of information is given. That is the mean of X is 6. Now find the missing value. What are the values of X which are possible? What are the corresponding probabilities? Let me call f of X. 0.2, 0.2, 0.2, 0.2, 0.2. For finding the mean, what do we need? So 0.2, 0.4, 0.8, 1.4.2x. What is the sum of this column? 1.4 plus 2.8 plus 0.2x. This is equal to mu, mean. And mean is given to us. What is that? 6. So 2.8 plus 0.2x equals 6. Solve it for x. So x will be 16. This is not a binomial distribution. For binomial distribution, probabilities are not constant.
It's equally like.
Binomial distribution probabilities are not constant. They depend upon the value of n and p. They are very rarely constant, usually not constant. Any other question? Because of equally likely. Any other question? Let me have 7 minutes. Let me rush. A multiple choice test contains 14 questions. Which test is this one? This is your major one. It will have 14 questions. Each question contains how many possible answers? This is actually your major one. Assume that a student guesses. This is really your major one. You'll be. This is really your major one. Assume that the student just guesses all of them. What is the probability that the student will get less than 2 answers correct? What is this question about? Who said binomial? How? First question is a trial. Yes, and this trial has how many possible outcomes? How many possible outcomes? How many results? 2 results, not 5 results. Your answer will be either correct or incorrect, either success or failure. What is the probability of success? 1/5. What is the probability of failure? 4/5. How many times are you repeating the experiment? 14 times. So here you are interested in number of successes, number of correct answers. So X here is number of successes out of n trials, 14 trials. Here X follows a binomial distribution where n is 14 and p is 0.2. And what is required? Less than 2. So you're supposed to find the probability of X equals 0 plus probability of X equals 1, not 2. 2. Equality is not included. And this will be 14 combination 0.2 to the power 0.8 to the power 14 plus 14 combination 1.2 to the power 1.8 to the power 13. Guess what are the chances that you will get less than 2 questions right? Or is it not erasing? Not a lot. 20% chances. Yes, you have a high chance of getting at least 2 questions right. There are at least 80% chance that you will get 2 or more than 2 questions right.
We have the same example, but we only used one letter. What would be the one?
What do you mean by use only one letter?
Like all day. How would the code be? Be similar?
Yeah. For all A, again, what is the probability that choice A will be correct? 1/5, same thing. Either you just guess or you pick all of them to be A. Same answer. Same thing, exactly the same. Some of you will do that, all A. I see it. Every semester. A slitter assembly contains 20 blades. 4 blades are selected and evaluated each day for sharpness. If any dull blade is found, the assembly is replaced with a new assembly of all sharp blades. If 3 of the blades in the assembly are done, what is the probability that assembly is replaced the first day it is evaluated? Okay, what I will do is, how many questions are left? 2 questions are left. I will continue sometimes in the evening. I will record the solution of these 2 and I will attach it on the Teams. I will record it inside the Teams and I will solve these 2 questions. Just a small hint, those of you who want to solve these 2, the question that I was looking at, that question is from hypergeometric distribution. Okay. And the last question, again, it tells you the distribution, that is Poisson distribution. Usually when they give you a question from Poisson distribution, they tell you that it has a Poisson distribution. Now, one of the very tricky questions I have seen in some exams is that they give you the Poisson distribution and they don't give you lambda. They don't give you lambda, they give you this. They tell you that X has a Poisson distribution and they tell you that the probability of X equals 0 is 0.4. Solve it, and what is probability of X equals 0 in Poisson? This is e to the power minus lambda, lambda to the power 0 over 0 factorial. This is the probability that X is equal to 0. Solve this equation backwards to get the value of lambda. So sometimes they tell you X has a Poisson distribution. They give you probability of X equals 0 and ask for probability X equals 1. 0 factorial is 1. E to the power 0 minus lambda is 0.4. So solve it indirectly for lambda. First get lambda, then find probability of X equals 1. So sometimes they give you the value of lambda indirectly through probability of X equals 0. So in this case, you have to solve it indirectly for lambda, get lambda, then they will ask you for maybe probability of X equals 7 or 4 or 3 or whatever. So you can use that lambda to solve it. So let us move on towards our next question. In this question, they say that slitter assembly contains 20 blades in total. So this is an important piece of information. 4 blades are selected. 4 blades are selected at random and evaluated each day for sharpness. Now here, because they are not mentioning that these 4 blades are selected with replacement or without replacement, so we'll assume by default without replacement. So out of these 4 selected, if any dull blade is found, the assembly is actually replaced with a newly sharpened set of 20 new blades. Now in this assembly, which consists of 20 blades, they say that if 3 of the blades in the assembly are dull. Now these 3 in the population, a population of 20, 3 of them they are dull, then what is the probability that the assembly will be replaced on the first day? So the question is something like, you have a population of 20. Out of these 20, you have 3 dull blades, and from here you are selecting 4 without replacement, and you want to see if the assembly will be replaced or not. So that means you're trying to find if the probability of X is more than equal to 1, because if you find any dull blade, according to the information, if any dull blade is found, the assembly is going to be replaced. So they are asking us to find the probability that the assembly is replaced on the first day. That means on the first day you will find a dull blade, any dull blade, either 1 dull blade or 2 or 3 or all 4 dull blades. Now this probability, the easier way of finding this probability is through the complement rule. So you can write this one as 1 minus probability of X less than 1, and the only value of X less than 1 which is possible is X equals 0. Now just plug in the values in your hypergeometric PMF, which is K combination X multiplied by N minus K combination small n minus x, 4 minus 0, which is 4 over uppercase n combination lowercase n. So this should correspond to 0.5088. You can do the calculation and you will see it will correspond to 0.5088. Now for the last question, it says that the number of content changes to a website follows a Poisson distribution with mean 0.15 per day. So they are giving you lambda 0.15 per day. What is the probability? What is the probability that no content change in the next 6 days? So probability that the number of content changes is 0 in next 6 days. You have lambda per 1 day, so you have to convert this lambda into per 6 days. This is easy. So it is e to the power minus lambda times t, lambda times t to the power 0 over 0 factorial. And I think this should correspond to 0.4066. So this is it. These were, I think, 11 or 12 questions belonging to chapter 3 in midterm or major exams from term 241 and term 233.